Hey, hello, folks. Welcome back to another workshop. To all the folks who are, wondering why are we having these regular workshops every day. So, and to the folks who are new to the stream, so we are hosting a hackathon for this complete week named Future Stack Gen AI Hackathon and sponsored by Cerebras. So in this hackathon, we have three tracks, one by Cerebras, one by Docker, and one by Meta. So we have $15,000 in total cash prize in this hackathon. So if you win one of the tracks, so for example, if you win Cerebras track, you win $5,000 in cash and an interview opportunity. If you win Meta track, you win $5,000 in cash plus coffee chat with Meta engineers, and also $5,000 in cash if you win the Docker track. But that's not it. We have, so while building the projects, you might run out of tokens, right? So we have Open Router here helping us to give more tokens. So if you are one of the first 500 hackers who go onto the VMakeDesk website and avail the voucher code given by Open Router, which is Open Router Cerebras Hackathon, you'll get extra tokens and $5 credit on Open Router. So make sure you do that. And if you're new to the hackathon, again, you can find all the relevant details about the hackathon in the description. So if you want to read about the hackathon, it's in the description. If you want to read about the rules, resources, it's in the description below, right? There are a few notes for you. Let's say if you want to win a raffle, social media raffle is also being going on. So what you have to do in order to win the raffle is you have to share about your project, about your journey of the hackathon, and tag Cerebras, Meta, VMakeDevs, Docker, all the folks, so that we get to know, okay, you have posted about the hackathon. If you haven't yet joined Cerebras Discord, make sure you do that, because all the hackathon reminders and updates are being shared over Cerebras Discord. And again, link can be found in the description. Or you can just head over to Cerebras website. You can find the Discord link over their website as well. And why I would recommend joining Discord right now is because they'll be having mentoring sessions tomorrow and day after tomorrow, right? So I would not want to miss that if I am working on a project in a hackathon. And these are straight from Docker and Meta folks. So make sure you join the Discord channel right now, and also join the mentoring sessions. I'll be sharing the details soon about these mentoring sessions over Discord and over our socials as well very soon. And if you are new to Gen AI, or if you're even new to AI, there was a course which was done by Kunal on this channel itself. It says Introduction to Gen AI. So make sure you check out the course, which will help you build good in this hackathon. I guess that was it. Now is the time we can jump straight to the workshop. And in this particular workshop, we'll be learning how you can build your own AI research agents using XI and Cerebras. And we have Pearl here with us. Pearl, would you like to give yourself a quick introduction?
Yeah. Hi, guys. So glad to be here. I'm Pearl. I'm on the Cerebras team. I've been here for about 6 months, kind of working under like growth and developer relations. So super excited to kind of show you guys what you can build using Cerebras. Can you pull up the slides?
Yep.
Thank you.
Yes.
Yeah. So that's me. Let's go here. So before we like officially get started, what I want you guys to do is I want you to scan this QR code to access the starter code. This is going to be an interactive workshop that you can follow along with me. So this QR code will be on most of the subsequent slides, but you're going to make sure to have access to this because this is going to kind of be the foundation for what you're going to be building along with me today. So I'm just going to pause for a couple seconds, let everybody scan it, hopefully. All right, if you didn't get it, it'll show up later. So in this workshop, what you are going to get are some free API credits through Cerebras and Exa, which I'm going to walk through how exactly to get those. You're going to get that quick start guide that I just shared that you can use to build other projects. And then you're going to have your very own deep research chat. And we're going to show what that looks like. Ayesh, if you could please share my tab. I'm going to pull it up right now. All right, it's ready if you want to switch that over. All right, so This is an example demo that one of our interns built actually, using the starter code that you see in the notebook. So let's just go. We'll do this question. What are the latest developments in quantum computing? So you have a research question, and then you can watch it work and see how quickly it does work. It's going to grab sources using EXA, um, and then it will do some analysis using Cerebras. And normally on something like ChatGPT, this would take 10, 15 minutes. Here, it took 24 seconds. So this is just one example of something you can use to build this. All right, we will go back to the slides now, please. Thank you. All right, so before we actually start building, let's talk about how deep research is done just by humans in general. So a lot of you have probably had to write a research paper at some point in your life. Um, and what you're going to do is you're going to start with a research question, right? With the example of quantum computing, how does quantum computing work? And then what you're going to do is you're going to find sources. Maybe you'll go to a library, you'll go to Google. If you're lucky, maybe you'll find interview an expert in your field that can give you more insights there. From those sources, you are then going to take notes, and then you're going to compile and analyze those notes. So, you'll take everything that you got from the sources, and then you will do kind of the more intellectual work of what does this mean, and then you'll actually put that into your paper. And in reality, this is a recursive process. You're not going to get all the answers in one pass. You're going to have to go through multiple sources. You're going to have to double check, make sure your sources are credible, etc., until you finally get your final research paper. So then how does this work with AI? So instead of going to the library, the AI is going to use tool calls, which are basically API calls to search with use a web search API. And then our AI system will autonomously break down the initial research question into those web search API calls to use to answer that question. And then the next step there, the kind of analysis part, is we are going to, I guess the taking notes part, sorry, is using retrieval or augmented generation, or RAG, where we basically are giving the LLM the context. Without it, it tends to be less accurate. It can kind of make stuff up. So with the RAG, we're basically saying, here are the sources to analyze, instead of just asking it the question directly. And finally, instead of us doing the analysis work, we are going to ask the LLM to do it for us. And then we are going to have a feedback loop. So our AI system is going to identify gaps in the output, and it's going to trigger any new searches if necessary. And it's going to repeat multiple times, basically until the LLM decides that the answer has been reached. And because we're doing so many LLM calls, this is where the speed becomes absolutely critical. And that's why we need Cerebras and EXA, because if you're chaining together 10 or 15 LLM calls to complete a research task, even small delays are going to add up quickly. And this is perfect for things like keeping up with fields like AI or biotech. It's good for answering questions such as what projects should you work on, for helping you with just kind of these questions that are not necessarily easily answered by a single Google search query. So now, sorry, I was off by one there. What we're going to do next is we are going to install our required packages. So if you go to the first block in your code, you are going to run it. Again, the starter code is right here on this QR code. And we are going to go and get our API keys as well. To get your API keys, you will go to cloud. For the Cerebras one, you're going to go to cloud.cerebras.ai, and you're going to click sign up. And then for the Exa one, you can go to exa.ai and you can click sign up if you haven't already done so. And then you'll just paste those directly in between the strings there. And while you're kind of installing those packages and grabbing the API keys, I'm just going to quickly talk about Cerebras and Exa and kind of what we do. So in today's workshop, we are going to be using Llama 4 Scout, which is one of Meta's open source models, and it's going to be running on Cerebras hardware. So Cerebras delivers 50 times faster inference than traditional GPUs, which obviously reduces your wait time. And the speed is critical for deep research workflows that are going to chain multiple LLM calls, as we talked about before. Most of these tools are going to take minutes. We can take seconds to do this, which is how we kind of unlock that new search. And then this is just kind of showing you, this is what the hardware looks like. This is a wafer scale engine WSE3, and it's basically this massive AI chip that's going to deliver that fast inference. And if you look at this benchmark, we are delivering the speed of around 2,600 tokens per second for Llama 4 Scout. And Exa is the web search piece of it. It's a search engine built from scratch specifically for AIs. So it's designed to make connecting LLMs to the web simple and seamless. And instead of just links, it's going to return the full content of the web page. So it's going to give the LLM the complete context. And you can see what that looks like in your code. So now that you've hopefully had a chance to get your API keys set up, and if you weren't able to get that working, never fear, you have the starter code after. You'll be able to go, and after we've kind of explained this, then you should be able to follow along yourself and do this later as well. So we are going to be building out our core search function using Exa. And let's kind of just like look at our core research diagram here. It's going to be this first box where we're going to take a question and we're going to find the relevant sources on the web. So if you go to step 2 in your notebook, that's where you're going to see the search function. It's going to look like this. And basically, let's just kind of walk through it. It's going to use the Exa search and contents endpoint, which is going to perform a web search, and it's going to retrieve the scraped content from each returned URL. So again, not just the landing page or the URL source, but the actual content of the page as well. The type here is set to auto, and auto basically means that it's going to automatically switch between different types of searches. So it's going to switch between a keyword search and a neural search based on the query. So for example, Python programming tutorials is just a keyword search. Something that's a little bit more complicated, like companies that are disrupting traditional banking, is going to be more of a neural search. And the text parameter is going to control how much content is retrieved from each source. And this is going to be really important for the research to get substantial content, not just the snippets. It's going to provide the context for LLMs instead of just the fragmented data. And then now let's try to run this function with a query like space companies in America. You can go ahead and do that if you want to go into your notebook and then just make the function call and just put that in as a parameter. What you're going to get back is the search results. You're going to get the full content from each page rendered as clean markdown. And you should see that there. And while you're doing that, I'll just kind of keep moving along, but that's just kind of something you can do if you're following along with this. And then on the output side, sorry, I got lost. Wanted to make sure I was on the right slide there. Basically, you're going to allow, this is going to allow the LLM to perform a deep analysis once you get this actual context. I'm going to go to the next one now. And then we're going, this next part is going to be doing the analysis work. So we use the web search to kind of grab our sources. We're going to take these sources and we're going to feed them into our LLM for the analysis. And this is going to be powered by Cerebras. And then this is where the RAG that we talked about happens. We're going to pass the LLM the context. And then again, this is kind of where the speed comes in. if we are giving it all these sources and it's going to take a long time for each response, that's where we get the 10-minute deep research queries instead of the 23-second one that I just showed you guys before. So let's look at what this actually looks like in the code. We're going to go to the Ask AI function, which should be right underneath the search function. It's going to take the content from Exa. It's going to feed it to the LLM. You'll notice that we set the temperature here. We're going to set it to a really low temperature of 0.2. You can think of the temperature as a creativity dial, basically. So a lower value is going to give us a more focused and factual response, and the higher value is going to give us more creative responses. Since we're doing research, we obviously want facts, which is why we have it set so low. And then, as we talked about, we're using Llama 4 Scout. It is optimized for kind of these more like reasoning and analysis tasks. And it runs on Cerebras chip, which is, again, where the speed comes from. And then let's also pay a special attention to the prompt structure, which I think is one of the key parts of this function to pay attention to. So instead of just asking something more vague, like, what do you think? We're providing very specific instructions. We're asking it to analyze the sources. We are asking it to answer the question. We're asking it to format the response clearly. I like to think of it as if you are giving instructions to somebody who is writing a research paper for the first time. You're not just going to say, go answer this question or go write this. You're going to say, here is specifically how I want you to do this. And so that's what we're doing for our LLM, basically. So it's going to read all the sources simultaneously, and then it's going to get you those insights. And that's kind of how that's going to be how that works. So you can go ahead and run that function yourself. You can try it with sample content. And then you'll be able to kind of see what that output looks like. So then this next part, if you go after the Ask AI function, this research topic function is going to kind of follow this like classic research flow. You'll ask a question, you perform an Exa web search, you're going to pass relevant responses to the LLM, then you're going to return a structured response. So you can kind of see, like in the function, if you look through, those are kind of the steps that it's going to go through. You'll search for the sources. You're going to filter for the substantial content, which is over 200 characters. You're going to create the context for the LLM. Then you're going to ask the LLM to analyze and synthesize the answers. And then if we also look at the prompt design, you're going to request a summary and specific insights. And then the output is going to be structured, and it's going to be a lot more useful than just a wall of text. So you can try running this function with things like a couple examples: climate change solutions in 2025, quantum computing advances, and then the function will find multiple sources and produce a real analysis, like you saw in the demo earlier. Now, if we want to take it a step further, we are going to make it recursive. So instead of just doing this research once and getting back one like form of results, we are going to basically prompt the LLM to identify important gaps and then do a targeted second web search. So essentially asking follow-up questions. And then that will kind of be, and this is where it is in your code. It'll add the intelligent follow-up layer. And it'll do this by asking things like, based on these sources, what's the most important follow-up question to deepen our understanding of the question? And then it will run that targeted search for the missing topic and gap. And then it will combine the initial and the follow-up layers. So the prompt engineering focus is specifically to identify the knowledge gaps. And then this will produce more richer and comprehensive results than just the basic version. And it will kind of do that iterative refinement that we talked about earlier. So this is just one piece of it. Everything we've built, if you'll notice, is really modular. There's a bunch of different pieces of it, and we can kind of add on to each piece if we want to expand this project. So we can add more search layers. We can maybe do things like integrate with specialized databases of things like academic papers, patents, financial data. We can add different types of analysis like sentiment, trend detection, or competitive intelligence. You could experiment with different LLM models, add memory between searches, or build kind of like domain specific research agents for technical due diligence, market research, or academic research. So there's just kind of a lot of different things you can do based on this scaffold. An example of this is you could implement a multi-agent system similar to Anthropic's. So basically how this works is you will have a lead agent that will break down the complex queries into specialized subtasks, and then multiple sub-agents will work on those subtasks simultaneously. So the lead agent will synthesize everything and then decide whether to launch more sub-agents or just to generate the finalized report. So you can kind of think of it if you have maybe a professor in a lab and a bunch of researchers. And maybe each researcher is researching one specific thing or has specific knowledge. And then the researchers will take their findings to the professor, and then the professor will help kind of synthesize that. Basically, the benefits of doing this are that it's going to keep the context manageable for each agent. And it's going to improve the reliability by giving agents well-scoped tasks. It's also going to increase the efficiency because you can run these in parallel, and it's going to enable dozens of searches at once. Instead of, having one person, you basically have a whole team that's working on this problem. And so if you look in your code, there should be a function example. It's the Anthropic multi-agent research function in the notebook, should be towards the bottom. And it's basically a simplified version of Anthropic's approach. And so it's going to be, again, more complex than the single agent flows, and it'll be better at handling difficult topics. So that's pretty much it. It's kind of up to you now to take this, and you can kind of build whatever you want to, but you now kind of have your own AI-powered deep research agent that is going to run in 30 seconds as opposed to 30 minutes. So thank you all. Yeah.
Yep. Thank you so much, Pearl, for going through all these slides for us. And I guess this was very short and quick and very clean. I'll just take few questions from the folks who have posted on our platform, then maybe we can conclude. And first of all, hi to everyone who has joined for the session, and thank you for being here. Can I use Hugging Face model in my project? Also, can you go through the project submission process? I'll just quickly tell you about the project submission process. So we'll release a form positively by tomorrow, wherein we'll ask you folks to submit your projects, and we'll ask some required details. It will be posted over Cerebras Discord, and we'll also share on the social, so you can find it over there. And also, we'll be adding it over the website. Pearl, would you like to take the Hugging Face part?
Yeah. So you can use Hugging Face models, absolutely. If you want to use us as a provider specifically, you can just go to the Hugging Face. Is there a chat somewhere where I could share a link specifically if you wanted to look at Llama 4 Scout, for example? Or maybe I can put this on the Discord.
Yep. Discord would be the best. Yep, it would be the best platform to post.
Offline, if you just let me know which channel so I don't cross any wires.
Yep. Just give it to me and I'll post it out. I'll post it.
Okay. Absolutely. Yeah, you can use Cerebras models on Hugging Face.
Sure. Redeem $5. That's great. Which model are we using in Cerebras?
In this workshop specifically, we're using Llama 4 Scout. As far as the models that we host on Cerebras, we kind of have a wide range. We have a few of the Llama models. So we have Llama 4 Scout, we have Llama 3.870B, Llama 3.18B. We have a couple Qwen models. We have Qwen 332B in production, and then we have Qwen 3235B in preview now, which you can try out on OpenRouter. We also have GPT OSS, which is one of our most popular ones, and Qwen 3 Coder as well. Those are probably our two like most popular models. The Llama 4 Scout was the one we used in this demo because it was the best one for the task. But you could switch them out. You can play around with different models.
Yep. Thank you for answering this one. And I guess we'll take the last question. Can't we simply use something like LangGraph?
Yes. um, I think the main point of like this demo is to kind of break it down into these like really modular things. Another thing is the kind of the value that Exa provides in particular is that it's gathering the full context, like the full source, if you can see the output of the function, um, which is actually giving the LLM the best context. Um, so I think that's a thing. And then also like using Cerebras as a provider is going to make it a lot faster.
Yep. I guess then we are at the end of the workshop, folks. If you haven't yet, joined the Cerebras Discord, I'll ask you to do it immediately, and the link can be found in the description. As far as code and all the other information for this workshop is concerned, I guess Pearl did share about QR in the starting of the workshop, so you can just go back and scan and then maybe revisit the workshop if you want. All the previous workshops can also be found under streams inside this channel itself. And make sure to check out VMaker's website. If you haven't yet registered, we have $15,000 in cash prize waiting for you. We'll hack till the weekend, and we have few good raffles as well for you folks. So thank you for joining, and I'll see you tomorrow and after tomorrow in Discord, Cerebras Discord, during the mentoring sessions. Yep. Thank you, Pearl. Any closing remarks you have for us?
No, super excited to see what you guys build. Good luck, everybody, for people who are participating in the hackathon.
Yep. Thank you. Bye.
Bye.